Well, hello there, everyone. This is going to be the week when we tackle chi-square statistical test. The chi-square statistic, test of independence, is the most common statistical test of significance. The chi-square test of independence assesses the probability that an association between two count variables is due to chance. And when I say count variables, I mean nominal level variables. So when we worked in our descriptive statistics and we had race, ethnicity, gender, when we reported those in counts. So chi-square looks at, are the variables independent of each other, or is there a relationship there? Like t-test, ANOVA does that with interval ratio level data and nominal level groups. Then chi-square looks at the relationship between two count variables, two nominal level variables. The challenge for chi-square in Excel is you do have to know the formula, and you have to work through the formula in chi-square to obtain your result. But you can do it. It's not difficult. It looks difficult, but it's really not difficult to do. It's just very systematic. So I'm going to take you through each step in the formula and how you build that in chi-square to arrive at our answer. So I promised you all semester you didn't have to know the formulas and you didn't have to memorize that. So now I'm breaking that promise, because for the chi-square we're going to have to do that. So you're going to have a practice exercise, and that's what I'm going to take you through in this video, is the practice exercise. For our practice exercise, we're going to ask the question, does men's voting preferences differ significantly from women's voting preferences? That's going to be our question. So right here, you now can see that we have a category of gender, men and women, and we're going to have a category of voting preferences. And you'll see that I've put that in as left wing, right wing, or center. So I'm going to, this particular slide right here, I will include both of these slides and upload them into D2L for you. However, on this particular slide right here, I've put a lot of the information on it about chi-square. And the chi-square test of independence, the hypothesis to test, remember we're testing a hypothesis when we do the inferential statistics, is gender and voting preferences are independent. Gender and voting preferences are not independent. Our null hypothesis is that there's not going to be a relationship between the gender and voting preferences, whereas our research hypothesis, we're going to say that there is a relationship between the gender and the voting preferences. To compute the chi-square, you have to know the expected frequency counts, you have to know the chi-square statistic, and you have to know the degrees of freedom. So that's what we're going to break down now with our data. I've provided you the data in the handout. And so what we have is we have a total of 400 men and 600 women. We're going to say that we sample surveyed 1,000 people who were reading information on COVID-19. And we wanted to know what their voting preferences were. So we sampled 1,000, and our results ended up, we had 400 males and 600 females. So let's hop over here to the example of how to break this down. And you'll see right here in my table 1, I've labeled this observed. Observed in the chi-square statistic means your actual data, what you actually got when you did your questionnaire and your survey. So here in the male observed, we have 190 who identified themselves as left wing. We have 155 who identified themselves in a center position, and we have 55 who identified themselves as right wing, and that's a total of 400. For females, we have 240 for left wing, we have 290 for the center, we have 70 for the right wing, and that's a total of 600. Coming down, we have a total of 430 of our participants who indicated they were left wing. We have a total of 445 of our participants who indicated they were center, and then we have a total of our 125 of our participants who indicated they were right wing. So when we look at these numbers, there's a couple right here that are really low. The left wing for the males and the center for the males is not too far off. It's about the same distance when you're looking at the left wing and the center wing for the females. But this really doesn't tell us anything other than count. It doesn't tell us if these are independent of each other and actually that more females are going to be center than left wing, or is all this just by chance? So that's what we're trying to determine here, is the level of significance, the level of, is this real, or did this kind of happen by chance? If we surveyed another 1,000 individuals who were looking up COVID-19 information, would we get the same kind of numbers? So the first thing that we're going to have to do is we're going to actually have to look at our chi-square the formula for the chi-square test of independence. And it's actually down here in the front of step 2. So I'm going to bring you right down here to the front of step 2. Let me bring this up here so we can look at this chi-square. This is the actual formula that we're going to be wanting to calculate, and we have to break down each of these steps to get the numbers to plug into this formula. So the chi-square statistic is the sum of the observed rows and columns minus the expected rows and columns squared divided by the expected rows and columns. It's not a complicated formula, but we have our observed rows and columns because that's the actual data that we collected. Now we have to get our expected rows and columns, and then we're going to have to calculate these two together and square them, and then we're going to have to divide them by our expected rows and columns. So right now we're missing our expected rows and columns. That's what we have to determine. So let's hop back up here to step 1, because step 1 is where we're going to get our expected rows and columns. We have to determine our expected frequency for the numbers of what we've observed. And the expected frequency is what we would think would happen given a true null hypothesis. So given that there is no relationship between voting preference and gender, what will we expect to see in our responses of males and females in their voting preferences? So the calculations for getting this is this formula right here in the green. The expected rows and columns equals, okay, we're going to take our number of rows times our number of columns. We're going to get a number for that, and then we're going to divide it by the total sample. So let me take you through this over here. I've given you the example here. Here is our observed information. Table 2 is our expected male. So what we've done is right here where it's left wing, I have taken the number in the row which is M12 or 430. Actually, this is the number in the column. So the total number of left wing in the column is 430. Okay. The total for the column is 400. And then I'm going to divide it by the total sample, which is 1,000. So essentially, to arrive at the expected for the males of the 172, I took 430, and I multiplied it by 400, and then I divided it by 1,000. And I forgot to put my equal signs up here at the front so it would do what needed to be done. And I got my 172. So let me walk you through that again. My 172 here uses this right here. It uses the cells that these numbers are in. But it's basically the column times the row total, column total, row total, and divide it by the total in the sample population. So let's do this again. So for the males of left wing, we would expect, and to get that, we're going to times 430, which is right there, the total for the left wing, times 400, which is the total for the row, and we're going to divide it by 1,000, and we're going to get our 172. But remember, in Excel, we've used the formula using our rows and columns. So we're going to do that for each of these. So we end up with 172 expected for the males under left wing, 178 expected under the males for center, and 50 under right wing. If our null hypothesis were to be true and there's no relationship between male and their voting preference, this is the numbers we would expect to see within our responses, okay? We're going to do the same thing for the females. So for the females, we actually have the total column. The total row here is going to be 600 for the females, and then divided by the 1,000. For center, we've got the total column. 445 is going to be divided, it's going to be multiplied by the 600 and then divided by the 1,000. So you're going to do the same thing. And now you've obtained your expected 258, expected 267, expected 75. So you have obtained what you would expect if your null hypothesis was true. The third thing you have to do is you have to calculate the chi-square statistic. And remember, the chi-square statistic is going to be the observed total of the rows and columns minus the expected total of the rows and columns. We're going to square that, and we're going to divide that by the expected rows and columns. So we're going to take each one of these, and we're going to break it down individually until we can actually calculate our chi-square. So right here, for males, I'm doing males. For the left wing, I need my observed minus my expected, okay? So let's go up here to my observed. My observed is 190, and I find it in M10. And I'm going to subtract that from my expected, and I find that in M16. And I come up with 18. So that's my observed minus my expected in males for left wing. I'm going to do the same thing across, and I can just drag this across, and it'll carry my formula across. Remember, they're at the bottom. So I've got a negative 23 for center and 5 for right wing, okay? Now I have to square this number. I have to do it to the second power. Again, it's not going to be difficult to do. We're going to come up here. We're going to highlight this square right here under the 18. We're going to come up here to our formulas. We're going to go to our more formulas, our statistic. We're going to find power. Where is my... Sorry, you're going to go to math, not statistics. I apologize. To find the power, go to the math and trig functions, and then pull down your menu, and then you'll get power, and you get this right here. And it wants to know the number. So For this one, it's going to be 18. And for the power, it's going to be squared, which is 2. So we get that right there. So we get 324, which is 18 to the second power. And we're going to do the same thing here. And then we want the observed minus the expected square, which is here, divided by the expected, which was up here, which is the 172. So right here, I'm going to say equals M30 divided by M16. And you can see those are highlighted. And I come up with this number right here. And again, I can drag this across. It's going to do that for each one. This right here, let me get this down to my 2 decimals, represents what the chi-square is going to be. And over here, we're going to sum it. We're going to get a total for it. So we have a chi-square statistic of 5.316. I've just done the same thing for the females down here. I just need to actually take this and do this, and then I need to sum it. Whoops. Then right here, I add this and I add this together. I add my 2 totals together and I get 8.93. So here I've actually just completed the components of my chi-square formula that I needed to complete. It arrives at the chi-square numbers for each of these categories. I add them all together. So for males, I have a 5.36. For females, I have a 3.57. I add those 2 together. It's 8.93, and that is my chi-square statistic. This right here is just the example where I broke down the numbers to get to the 1.88. I demonstrated it right here. So now we have to determine the level of significance for our chi-square. No, I'm sorry, back up. Step 3, we have to do degrees of freedom. We have to determine our degrees of freedom for this because the formula doesn't do it for us. So the degrees of freedom equals the total rows minus 1 times the total columns minus 1. So to obtain this number, we take the number of rows, rows minus 1, and multiply it by the number of columns minus 1. So in our example, we have 2 rows, males and females, and we have 3 columns, left, center, and right. So that gives us the formula of 2 minus 1 times 3 minus 1 equals 1 times 2 equals 2. So we have 2 degrees of freedom. So you can look at that again. It's very simple. It's the number of rows minus 1 times the number of columns minus 1. So we end with 2 degrees of freedom right here. We have to have that when we report our chi-square results. Now we have to determine the level of significance. Is this significant? If you'll think back, when we set our hypothesis, we're going to set an alpha level, and our standard is 0.05. And anything lower than that is going to be significant. Anything higher than that is not going to be significant. So how do we know if what we've gotten here, if our 8.93 is significant or not? So to determine that, we have to run the chi-square test. So the first thing you have to do is you have to extract your numbers and put them side by side, like we've had to do with the t-test and the ANOVA. We have to have those categories side by side. So we need our men, we need the observed numbers here. We have 190, 155, and 55, which is male left wing, male center, male right wing. We need the women next to it, observed, 240, 290, 70. Okay, then below it you need to put your men expected and your women expected. So you need to create this table like this so that you have these numbers together to do your p-value, which is your alpha value or your chi-square statistic. So to show you how to do this, I'm going to take this out and I'm going to come up here and I'm going to go to more functions. I'm going to go statistical, and I'm going to find my chi-square test. So this is my chi-square test right here. I'm going to click on my chi-square test. I'm going to do my actual range, which actual is observed, and that's going to be these right here. I'm going to do my expected range, and that's going to be those right there. And then I'm going to hit OK. So it gives me a chi-square of 0.011527. We're really interested in that 0.01. 0.01 is much lower than 0.05. So this means we have a statistical finding, and it means that we can reject our null hypothesis, and that in fact there is a relationship, or the fact that gender is not independent of voting preference. Gender is influencing voting preference in the 1,000 people that we surveyed. So let's come over here. We set our level of significance at 0.05 and obtained a level of significance at 0.01. This means we will reject our null hypothesis that gender and voting preferences are independent and accept our alternative hypothesis that gender and voting preferences are not independent. So how are we going to write our results? Right here's the example. A chi-square test of independence was calculated comparing the frequency of voting preferences for men and women. A significant interaction was found, and then we write our chi-square formula here, our results. Chi-square, we have 2 degrees of freedom. Our chi-square statistic was 8.92. Our p-value was 0.01. Then we're just going to make the statement. Women were more likely to have a voting preference than men. So women were 60% of our sample reported a voting preference more often than men, which was 40. Actually, that sentence right there doesn't make sense. Let's just take that out. So women were more likely to have a voting preference than men. I'm sorry, I'm taking that out too, because that just doesn't make sense either. I didn't include the other. So when we say this, we can actually look at how women were more likely to have a voting preference for the center than men. Women were more likely to have a voting preference for the left than men, and for the right than men. So therefore, the women did have more of a voting preference. They aligned more with the voting preference than what men did. But to report your chi-square statistic, this is the one sentence that you would have. A chi-square test of independence was calculated comparing the frequency of voting preferences for men and women. A significant interaction was found where the chi-square with degrees of freedom was 8.92 at a p.01 level. So this is your practice exercise. It's not as complicated as it looks. You just have to break down the steps to get the numbers you need to plug into your chi-square statistic. So I'm going to put my examples up here, and I'm going to upload the step-by-step instructions. So this week, I just want you to go through and do this practice exercise, And then I'm going to give you two variables in our client data caseload to do the same thing with, and you'll just follow these same steps. Again, it looks complicated. It's really not. Once you understand how you're breaking down and getting those numbers, you'll easily be able to plug the numbers in that you need for this particular assignment. And that is the chi-square statistic in Excel.